Now, let us start the event with praise song. Prayer delights God's ear. It melts his heart. Now let us stand for the praise song and invoke the God's blessings through the praise song. Please be seated. The path of life is the quest of knowledge. I invite our rector, Reverend Dr. Henry Zenon S.J., our secretary, Reverend Dr. Alphonse Malik S.J., our principal, Reverend Dr. Mariela S.J., our head of the department, Dr. V. Premanand, and our coordinator, Dr. Mary Cherila, to light the Kutuba. Small cheer, great welcome, make merry feast. Now I call upon Dr. V. Delina, Assistant Professor of Physics, to welcome the gathering.
This is the day that the Lord has made. Let us rejoice and be glad in it. Psalm 118, verse 24. New day, yet another gift from our Creator, another golden opportunity to live something of the happiness we bring. I thank the Almighty for this wonderful opportunity to propose the welcome address. Good day to everyone present here. I welcome you all to this international conference on emerging materials and its application, ICEMA 2022. Innovation distinguishes between a leader and a follower. I am performing honor to welcome our beloved rector, Reverend Dr. V. Peter S.J., who is like an umbrella to this prestigious institution because he protects and upholds the institution with the utmost care and support. We welcome you, Father. I would like to welcome Dr. S. Raj to honor Reverend Father Rector with a shawl. Thank you, sir. Small steps in the right direction can turn out to be the biggest step of your life. I humbly welcome our respectful secretary, Reverend Dr. Alphonse Marino SG, who has always been with us to assist us in unimaginable ways. Thank you for being with us and for being a guiding light. We welcome you, Father. Now, I would like to welcome Dr. S. Anna Venus to honor our Reverend Father Secretary, Vishwa. Thank you, dear man. True leaders always practice the three R's: respect for self, respect for others, responsibility for all their actions. I can never refrain from welcoming our beloved principal, Reverend Dr. Ismailas SG, who is guiding us by his understanding, supportive, and confident qualities. We are and we will be grateful for your continuous contribution, Father. We welcome you, Father. I would like to welcome Dr. R. Mary Jelena to honor Reverend Father Principal Vishwan. Thank you, ma'am. I also extend my warm welcome to our keynote speaker, Reverend Dr. Francis P. Xavier SG, for accepting our invitation. We welcome you, Father. I heartily welcome Dr. V. Indraj, a former Associate Professor of Botany, for his readily accepting our invitation. We welcome you, sir. With immense pleasure, I welcome the head of the Department of Physics, Dr. D. Premanan, who has inspired minds with his immeasurable deeds. We are delighted with your expertise and knowledge in all the ways it is possible. We welcome you, sir. Knowledge is like a garden. If it is not cultivated, it cannot be harvested. I wholeheartedly welcome our speakers across the country who have come here to share their valuable time and experiences. They are here uniquely placed to discuss and highlight the trends and reforms. We are honored to have you all with us, and also we are grateful to you all for accepting our invitation and coming over for the conference here today. We welcome you, sirs. I bid a warm welcome to our sponsors who have contributed generously towards this conference. And it is a pleasure to have you all with us. We welcome you all. I would also like to offer my regards to all the people who made this conference functional in such hard times. Before moving further, I extend my greetings and appreciation to all of my department professors, where works made us co-workers, but our conversations made us friends. My hearty welcome to the organizing team. A good beginning makes an excellent end. I extend my warm welcome and lab technicians who made this aviation a reality and a successful one. This would not have been possible without the sheer contribution of you all, as we all are a part of this prestigious institution. Our passion unites us and our hard work strengthens our institution. I want that the conference will be productive and worth your precious time. I wish you all the best and hope you all will have a pleasant stay here. I sincerely hope that all will enjoy today. We will be delighted to have your suggestions and questions at the end of the event. I declare that the conference is open for further proceedings. Once again, I welcome you all. Welcome.
Thank you, Professor, for your warm welcome. He is well known for his kindness, great vision, and hard work for the growth of our college. He is our beloved rector, Reverend Dr. Henry Jerome S. Now I invite Reverend Father Rector to deliver the presidency letters.
The Father Secretary, Father Principal, Resource Persons, Father Francis Xavier, HOD, Coordinator, Professors, guests from other colleges, and my students. Good morning to all of you. E.F. Schumacher, a German-born British economist, wrote a small book. Any of you know the title of this book? E.F. Schumacher. Okay, that is Small is Beautiful. That was published in 1970. Those people who love to read philosophy, politics, and economics can read that book. It's available in the net. Small is Beautiful. The title itself is very inspiring. Small is beautiful. In fact, he got this principle from his teacher, master, Leopold Koh, who advanced small, appropriate technologies, policies, and policies as a superior alternative to the mainstream because of bigger is better. You know, as a concept, you will find that the small is beautiful will be relevant to all physical, biological, and social sciences. Emerging materials also deal with small things. They are beautiful, they're impressive, they're interesting. We speak about emerging materials, but the problem for all of us, human beings, we will be able to express anything about anything only from the experiences that we have got with the existing material. Suppose I want to say this about this wood, then I know that this existing materials will give me some understanding, and I can say this from the street is taken, and then it will stay on study. All those things I will be able to say only because I have the knowledge of existing materials. Now the challenge for all of us, particularly for the physics students, will be to reflect on everything from emerging materials, the smaller and smaller. As students of science, we should be able to speak about anything from the experience of emerging materials. Emerging materials lead us into the depth of science. It is a revolution that's going to make a revolution, like theory of relativity, when it was propounded, that it revolutionized whole physics, and in fact, whole planet. And now the emerging materials also now will certainly revolutionize the physics and all other fields. The detection of Higgs boson, for example, that was termed as hot damn, because they said more than this could not be detected. It was so small. We all thought only that atom could be neutron or electron or proton, but now the Higgs boson opened up the eyes of the scientists. That's something beautiful. Now it is not that part, then they term it as not particle, because more than that cannot be detected. And that's playing a very important role in particle physics. I'm sure that emerging materials also will be playing a very important role in polar physics. And we understand the more smaller things are dissected, the more bigger the researchers are. When more researchers are taken in the field, academicians will be able to possibly forecast the future with exploratory statements that will have high level of mathematical certainty. Nanotechnology combined with neuroscience, mechanics, and in the field of artificial intelligence, all that IoT or any other field, now is going to be the future for certain. Biomechatronics is a big thing that's going to happen. Genome modification will be certainly possible so that human beings will live without diseases. Then why do we have pandemic now? All this other now? Probably we are in the transition. We are the transition generation. We are not normally new generation. We are now moving on from the human intelligence, importance of human intelligence to the machine intelligence. There will be a time you will find that all of us can expect that these two intelligences, both human and artificial intelligences, would merge into one. Maybe artificial intelligence will surpass human intelligence. And that generation will be, I don't know, gifted. Our generation can use a mobile only for talking. You people can use for, say, playing games and other things. I'm sure the future generation, your brothers and sisters, will be certainly believe in the mobile. And therefore, you find that when that comes, when the artificial intelligence will surpass the human intelligence, you will find that the world will not remain same. There will be many possibilities and problems that will disturb the new generation, like what we see in genome modification and so on. Emerging materials will lead us into such revolutions. Therefore, it is not going to be a concern only for physics, but for the entire humanity. All of us will have to be alert, and the young people like you will have a greater role to play in that research. I'm happy that the Department of Physics has thought of such a relevant theme for its international seminar. I was also happy to know that there will be many papers will come to be presented here. I'm sure it will open up our eyes to see the future with real eyes, real academic eyes, which will help us create a better philosophy of life. I wish you all the best. Thank you very much.
Thank you, Father, for your highly motivating words. Felicitation is inspiration to others and motivation to whom you are felicitating. He is the man of knowledge who never fails to appreciate your needs. He is none other than our beloved secretary, Reverend Dr. Alphonse Maria. Now I invite Reverend Father Secretary to deliver the words of felicitation.
Good morning to all of you. Respected Reverend Father and our rector, Reverend Father Maria, our principal, Dr. Preman, the head of the department, Dr. Shalila, the coordinator of the program of Shift 2, Reverend Father Dr. Francis P. Xavier, the one to offer the online keynote address of this conference from Royal College, Chairman, Dr. Iliraj, the retired professor of our department, who has come over here to share his rich experience of teaching learning in the same department. professors and scholars from various institutions, and dear members of the staff and students of the department. I'm indeed very glad and much pleased to see that the Department of Physics has organized a relevant international conference at the very beginning of this final semester of this academic year. And we are very fortunate to have a semester which will have no disturbance, no lockdown, no fear of the virus, and so on. We only hope and pray that till the last day of the semester, everything will move well, and this will be something beautiful that we will be blessed with. Now, emerging what? We talk, we hear of emerging trends, emerging fashions, emerging cultures, emerging technology, etc., etc. If one could ask a historian, I would say emerging kingdoms, emerging leaders, etc. But emerging materials, only students of physics would be able to understand what does it mean, emerging materials. It could be a tiny dot, or it could be a mass of things. But whether it is a tiny one or a huge one, the power it contains is something uncontrollable and unlimited. Such a power a tiny atom has. This is what you have been familiar with in your subjects of studies. But what are the new emerging trends in physics, in different materials? If we go to the war zone, Ukraine, Russia today, what are the new emerging technologies they use for the war? The development of society, how does the new technology help in developing the society, the facilities? These are something very possibly analyzed. But as scientists, as research scholars, as students and staff of physics, your thinking is entirely different. Your field is totally different from us. I don't think I'll be able to define what are the various emerging materials in physics in today's context. And this is the reason why this international conference is being organized by the Department of Physics for the benefit of the staff and students from different institutions. You have very potential expertise to address you, to motivate you, to challenge you on the topic of the conference. And one such expertise is Reverend Father Francis Xavier, the rector of Royal College, a great scientist and a professor of physics from Royal College. You have to look forward to his beautiful lecture on the topic, which will be something very enlightening, motivating, inspiring, and inviting you to be a scientist, to be a scholar, to be a student and staff working out of the Department of Physics. When I was talking about the power of time matter, I'm only reminded of what yesterday I had a conversation with some friends of mine. They said, somewhere in the conversation, the word power theory, power. Those who study in St. Xavier's, those who teach now and study now in St. Xavier's, they have this concept that there is the power in the campus. There is a power in the institution. When I say the campus institution, it is the St. Xavier's institution. There is a power. The power is something that you cannot imagine. It is not just really a human power. There is a divine power in this institution. Those who shared with me have experienced this over the years. This institution could face any kinds of problems from any quarter, but it will withstand because it has a divine power. These are not my words. This is what some of the staff of this college, teaching and retired, have shared. That is the power, divine power. You and I cannot really miss it, but we should experience it. That is something that we have. Physics is power. Atom is power. Emerging materials give a lot of power. But for what is something that we should look forward to. I only wish and hope that the orientation today, the lectures today, will enlighten you on another aspect. And I take this opportunity to thank and appreciate the department, starting with Professor Premanand, the head, and all the other professors and the students, both UG and PG, for having organized such a wonderful topic for uniting humanity today. Thank you. God bless you.
Thank you, Father, for your words of persuasion. He is highly passionate about delivering the best to students and to infuse hope among the learners. He is none other than our beloved principal of college, Reverend Dr. Maridas S.J. Now I invite Reverend Father Principal to deliver the inaugural address.
Respected Reverend Father Rector, Reverend Father Secretary, Head of the Department, Coordinator, Reverend Father Francis Xavier, Dr. Yuri Raj, the participants, professors, and my dear students. Good morning to you all. Good morning. Thank you. I'm very happy to be with you all this morning as we are having the inaugural portion of this one-day national seminar on the emerging materials and its applications, organized by the Department of Physics. I was just talking to the HOD. Had it been yesterday, being a science and national science day, you would have been more appropriate, I thought. There's only a regular chat. Yesterday, I had to read the central page of the Hindu. There it was given an article on the National Science Day. And the theme of this National Science Day for this year says integrated approach in science and technology for sustainable future. This particular theme implies two aspects. One is integrated approach and the other one is sustainable future. And how we are going to have integrated approach and ensure sustainable future for all of us, whether we live here or elsewhere, is an important issue for discussion. I am sure the discussions and deliberations that we are going to have today, full day, will enlighten all of you, all the participants on these two aspects, having an integrated approach, not a compartmentalized approach, but an integrated approach to ensure a bright and sustainable future for everyone. And the same article says, now the academic freedom is a great question. The national, taking into account the national science or national aspect, the author discusses that the academic freedom in all institutions or the entire country is a great question. And so the author ends the article saying that we need to have a shift. And what sort of shift he proposes? A cultural shift has to be so that people will be able to imbibe this integrated approach and ensure sustainable future. So I'm sure we will have a discussion and you have great scientists, Father Francis Xavier, international scientists, you will be able to enlighten you on this particular aspect of how to have integrated abilities, a right person for this particular topic on the emerging materials and its applications. The same author, he ends the article saying that we need to ensure all the scientists, all those who are involved in the scientific approach, he urges and says we need to ensure unfettered intellectual ambience to promote the spirit of science. Because he says that it is disturbed, intellectual ambience is very much disturbed because of various aspects. That's where he brings out the cultural shift that has taken place in all of us within the culture or outside the culture. Therefore, I am discuss about our next 2 days. Today, it will help you to have an integrated and wholesome approach so that we all become role models in the future. I'm sure this is a very relevant topic as it aims this particular aspect. I extend a warm welcome to all the participants from other colleges, other institutions. This day's deliberations and discussions help all of you for unleashing tremendous transformative power so that we become the role models for all of us. Thank you very much. We go on this one.
Thank you, Father, for your positive and powerful words. Better than 1,000 days of diligent study is one day with a great teacher. I invite our head of the department, Dr. Premanand, St. Xavier's College, Malayalam, to explain the scope of this conference.
A very good morning, Reverend Fathers. This international conference on emerging materials and applications will be one of the international meetings exclusively dedicated to emerging materials and solid state physics. We hope that the event will be extremely useful to researchers working in the field of solid state physics, material science, solid state ionics, as the people with diversified backgrounds are expected to attend this conference and making the event truly interdisciplinary in nature. This international conference on emerging materials and its applications is a unique event and a platform for global scientists, researchers, directors, professors, students, scholars, and engineers from the research areas of material science to share their knowledge and research experiences with interactive panel discussions and sessions by keynote lectures, oral presentation, and poster presentation. The scientific session comprises research areas of advanced materials such as solid state materials, polymer science, material science, nanotechnology, carbon materials, energy materials, conductive materials, electrical and optical materials, magnetic materials, and supercapacitor applications, and so on. And what is the importance and scope of this international conference? So this conference provides the best opportunity for delegates from various institutes and universities to interact with superlative scientists and material experts worldwide. It acts as a dais in linking academicians and industries to transform the innovative research works into products. So the ultimate aim of this international conference of emerging materials and applications is that so every material should be converted into product for the application usage. Therefore, the sphere of material science is the interdisciplinary field connecting chemistry and physics, which concentrates on the properties of materials and their microscopic properties. The advancement in the material science leads to the designing of novel materials, and it also provides evidence for engineering applications. And materials are dynamic for the and so socio-economic development in the society. And therefore, this emerging materials and its remarkable technology in the new area expose exciting advancements in micro and nano engineering. The proceeding importance of material science is also to recognize the required material or a combination of material on its cost and its usefulness. So I hope this international conference on emerging materials and applications will be useful for the mainly for the research scholars, scientists, and professors from various institutes. Thank you.
Thank you, sir, for explaining the purpose and scope of this conference. Now I invite Reverend Father Rector, Reverend Father Secretary, and Reverend Father Principal to release the so many of the conference proceedings. Now I invite Dr. Agustin, Assistant Professor of Physics, to introduce about our keynote speaker, Reverend Dr. Francis P. Xavier. Good morning to all. A very good morning to all. Well begun is half dead. Yes, dear fathers, friends, and participants, today we are going to start this conference with the keynote address by our beloved, respected Reverend Father Dr. Francis P. Xavier, S.J., Rector of Loyola Institutions, Chennai. It's our privilege to have such a eminent personality for this keynote address of this conference. Our speaker, our father, going to explain the basic tone and the theme of this conference, and that will definitely resonate us. Our Reverend Father, Dr. Xavier, did his BSc degree from Loyola College, Chennai during 1974 and a MSc at St. Joseph's College, Trichy during the year 1977. Following his PhD at Boston College, USA during the year 1992.
Along this academic qualification, father also had philosophy and theology degrees like Bachelor of Philosophy from Janadiba Vidyapith, Pune during the year 1981 and Master of Divinity at St. George, Germany during the year 1986. Father has a vast research experience. He working as a visiting scientist in Boston College, USA during the year 1993 to 2016 and visiting faculty at Stockholm University, Germany during the year 1998-99. Father then collaborating research work at Boston College and also with the Crystal Grove Center, Anna University, Chennai. Father was the founder and director of LIFE, that is Loyola Institute of Frontier Energy, Loyola College, Chennai. Our father mainly working on the research area of organic photoconductors. Father published more than 24 books and 159 articles in various forums. Along that particular articles, Father also published religion and science-related articles. Father, as a research under his guidance, around 10 people were in his PhD and 9 people finished their degree. Father also organized 16 conferences and presented 53 papers, including national and international conferences. Father put the burden of digital community sensor during the year 2004 and 3-zone furnace for coal facilitation. Father as a research person in various areas, management, administration, education. Regarding the administration experience, Father working as a worked as a vice principal in Loyola College during the year 1994 to 1998. Father hold the position of Jesuit Provincial of Madurai Province during the year 1999 to 2005. He working as a chairman of Jesuit Education Institution, Tamil Nadu during the year 1999 to 2005. And also, Father was the founder and director of Loyola Institute of Frontier Energy and founder director of Loyola College of Engineering and Technology. And Father worked as a vice president, Jesuit Worldwide Learning Geneva during the year January 2017 to 19. So with this introduction, on behalf of the Department of Physics and Sciences College, we warmly welcome our beloved Father, Reverend Dr. Francis P. Xavier to deliver this keynote address. And thank you for this opportunity. Thank you.
Dear Reverend Fathers Rector, Secretary and Principal, Dr. Premanand and organizers of this international conference, invited speakers, and all the participants, good morning to you all. Am I audible? Am I audible? Okay. We are gathered here as researchers to compare notes and to share our expertise and experience with regard to what is the urgent need in the world and what is setting the trend in research. Let's begin with our common understanding of science, starting with Einsteinian equation E is equal to mc square. We are familiar with the concept and examples that matter could be converted into energy. But we might find it difficult to convert energy into matter, though theoretically it should be possible. But our search or research should have a direction, purpose, and meaning. For example, in our research, we find out as matter turns into energy, we also realize that energy in turn should give rise to consciousness of others and their needs, and hence to make our research enrich their lives. David Bohm, an American-British scientist, argues that reality is tripartite, namely mass or matter, energy, and consciousness. He would state, I quote, consciousness is a coherent whole which is never static or complete, but which is an unending process of movement and unfoldment, unquote. Hence, this would bring in our commitment to make our environment meaningful and lasting. The whole process should revolve around ethics in order to give us the overall meaning about research. In a world of multinational companies, where exploitation of the people and amassing profit, our research should bring in the value that people should be more important than profit. In other words, ethical values should be the principle and foundation of any scientific research. Interdisciplinary research is the order of the day. We tend to think that our area of specialization is the most important in the world of research. But we need to understand that our research should complement other research areas, and hence inter or multidisciplinary research is the need of the hour. Take, for example, physics. Electrical charges are proposed to play a role in wound healing. In a normal skin, the external skin surface is always electronegative with respect to the inner skin layers. In contrast, in the case of a wound, it becomes positive compared with the surrounding intact skin, and as healing processes, this potential changes. A few decades ago, it was tried by keeping a silver mesh in the wound area and applying mild electricity so that positive charges could be induced to accelerate the healing process. There seems to be clinical evidence base for silver dressings in the management of contaminated and infected acute and chronic wounds. Using silver mesh, when compared with sulfadiazine cream, seems to yield better result in treatment of pressure ulcers. We could see that physics and chemistry are at the service of biology, not only to understand the mechanism, but understand the living beings better. A single atom of physics and a molecule of chemistry become alive when they become an integral part of a biological system. Thus, physics, chemistry, and biology are complementary, and when they converge, they become alive, meaningful, and useful. Today, physics has branched off into various areas of specialization, such as biophysics, chemical physics, medical physics, and has now enriched with nuclear medicine, photon therapy, etc. And further, we have astrophysics, condensed matter physics, electronics, etc. Now, the emerging trends in research is application-oriented, and we can look at some of the materials. My memory goes back to my own research, doctoral research. It was in the area of chemical physics. I was investigating the optical and transport properties of phthalocyanine and related compounds in 1990s. Phthalocyanine belongs to the family of aromatic macrocyclic organic compound. It, especially copper phthalocyanine, became a leader in dyes and pigments. Prior to copper phthalocyanine, no one could paint the car in blue as it was bleached by the sunlight. I was studying the optical and conductivity properties of the material, and discovered that organic photoconductors have one, multiple conduction bands, and two, molecular properties dominate the characteristics of the organic semiconductors. This is in contrast to inorganic semiconductors, where the crystal determines the properties of the material. Commercially, phthalocyanines are much used as important class of colorant, and copper phthalocyanin is the single largest volume colorant sold today in the market. Traditional uses of phthalocyanin colorants are as blue and green pigments for automotive paints and printing inks, and as blue or cyan dyes for textiles and paper. Further, phthalocyanin has similar structure to hemoglobin, with its high extinction coefficients and long absorption wavelengths in the near infrared region. Phthalocyanins and naphthalocyanins are well suited for optical imaging and phototherapies in biological tissues. As phthalocyanins are synthetic analogs of porphyrins, they are employed as photosensitizers in cancer therapy. In recent years, active research fields include electrophotography, photovoltaics and solar cells, molecular electronics, Langmuir Blodgett films, photosensitizers, electrochromic display devices, gas sensors, liquid crystals, low-dimensional conductors, and optical discs, and many more. Now, light-emitting diodes are coming in a big way. Organic light-emitting diodes are preferred candidates for low-cost, low-energy consumption, and long-life flexible displays. The metal atoms in organic derivative forms, such as penanthroline, comprising the cathode, enables electrons to be extracted with less energy than is otherwise required. These organic derivatives are stable and resistant to degradation from oxygen or moisture. In the diagnostic technology, living cells are put into a tiny biochip and is then implanted into a patient. These living cells can detect biological changes within a patient's body and send feedback to the patient and the doctor about problems or impending illness. Another area of interest for future development is protein-based biochips. These biochips could be used to array protein substrates that could then be used for the drug lead screening or diagnostic tests. If a biosensor apparatus is built into this biochip, a further application might be to measure the catalytic activity of various enzymes. The ability to apply proteins and peptides on a variety of chip substrates is currently an area of intense research. Now let us look at the new materials for application-oriented research. Experimental interest for future applications has attracted piezoelectric materials. Piezoelectric materials play a vital role in electronic devices such as actuators, sensors, accelerators, ultrasonic motors, transducers, filters, and resonators, as well as microelectrochemical system. Energy harvesting devices with higher overall efficiency, stability, lifetime, and low self-cost of materials such as piezoelectric, pyroelectric, and electret ceramics and their composites invite interest. At the same time, new physical principles regarding multimode vibrations and complex deformations attract attention as well. Some of these new materials of interests are organic superconductors, rare earth optical amplifiers, high field magnets, magneto-optical recording materials, porous silicon, quantum dots, gallium nitride, and many more. Looking at the two-dimensional materials for electronic applications, we are living in a knowledge society of artificial intelligence in an age of digitation. We are looking for new materials for modern applications. The successful isolation of graphene in 2004 has attracted great interest to search for potential applications of this unique material and other members of the two-dimensional materials family in electronics, optoelectronics, and their interface with the biological systems. Making use of the unique properties of graphenes for RF applications, novel applications are developed to design many fundamental building blocks of RF electronics, such as frequency multipliers, mixers, and binary phase shift keying devices. There are other materials such as molybdenum disulfide with the potential for high-performance flexible electronics. There are some smart materials as well. This is yet another family of materials known as smart materials. These could be manipulated to respond in a controllable and reversible way, modifying some of their properties as a result of external stimuli, for example, certain mechanical stress or a certain temperature, etc. As they are responsive, smart materials are also known as responsive materials, which could be labeled as active materials. More accurately, they are reactive materials. They are classified as piezoelectric materials, shape memory materials, as they could return to their original shape when exposed to external stimuli, chromoactive materials, which react or respond to variation in temperature, light, and pressure, magnetorheological materials, which could be used as shock absorbers to prevent seismic vibrations in bridges or skyscrapers, photoactive materials, and many more. Material science is constantly coming up with new discoveries that would revolutionize our future. Let us look at a few examples. One, synthetic spider web. This family of material is not only 5 times stronger than steel, but also has great elasticity. Its potential uses include bulletproof clothing, artificial skin or burns or waterproof adhesives. 2, Shrilk. It is a fully biodegradable plastic. Its main component is chitin, a carbohydrate found in krill shells. It was created by researchers from Harvard University and is considered as the ideal substitute for plastic. Its decomposition time is only 2 weeks, and it also works as stimulant for plant growth. 3, conduction polymers. When exposed to electric or chemical stimulations, the electrons can move from one end of the polymer to the other. Dielectric elastometers, also known as electrostatic polymers, can reduce or increase its volume by 30% when exposed to electric field. They are used for building artificial muscles for robots. 4, smart gels are made of cross-linked polymer network inflated with solvents such as water and can reduce or increase its volume to 1,000 times. They can be programmed to absorb or release fluids in response to almost any chemical or physical stimulus. And 5, metallic carbon nanotubes have also been proposed for nanoelectronic interconnects since they can carry high current densities. Now, we are more and more becoming enlightened by the need and use of multidisciplinary research in order to address ever-increasing complex challenges and changes. Let us think of 2 areas, namely biodegradable plastics and robots or xenobots. When we think of substitute for plastic, we could think of biodegradable plastics as well. Stanford researchers have recently discovered plastic-eating worms. This may offer solution to the mounting wastage and garbage in the world. The mealworm, which is the larvae form of the darkling beetle, can subsist on a diet of styrofoam and other forms of polystyrene. The worms converted about half of styrofoam eaten into carbon dioxide, and they would, with any food source, and the rest of the remaining plastic is excreted as biodegradable fragments, which could be used safely as soil for crops. This has opened a new door to solve the global plastic pollution problem. This is another area of interdisciplinary research. Scientists who could bring up the world's first living robots think that these can replicate and generate offspring. It is believed that this could help us explain the origin of life on Earth. In December 2021, that is a couple of months ago, researchers in the University of Vermont, USA, have enabled new life forms known as xenobots to produce offspring. The biological robots were designed on a supercomputer by artificial intelligence, then built in real life using embryonic stem cells from a frog. When the team tested the AI's design in the lab, they were amazed when the xenobots actually started self-replicating. I would conclude with mentioning the top 10 advances in material science today. 1, International Technology Roadmap for Semiconductors as a combination of science, technology, and economy. 2, Scanning probe microscopes, paving the way for nanotechnology. 3, Giant magnetoresistive effect to produce real space images of electrically conductive surfaces with sub-nanometer and spatial resolution. 4, semiconductor laser and LEDs, which form the basis of telecommunication, especially LED, which is not a conventional light source, rather an electronic source related to the transistor. 5, nanotechnology. 6, carbon fiber reinforced plastics, revolutionizing transport, packaging, civil engineering, and sport. 7, lithium-ion batteries, leading to prolonging battery life. 8, carbon nanotubes, especially fullerene tubes, arousing greater interest. 9, soft lithography, creating an attractive route to microscale structures and systems needed for applications in biotechnology. And 10, metamaterials, opening the vista for novel applications such as lightweight lenses for radar waves. What is the future direction? With regard to our future collective endeavor, we need to think of multidisciplinary research, which would be useful for the society at large. The need of the society in general could be considered energy and environment, and our research and its application should have ethics as principle and foundation. In a critical and challenging situation like pandemic aftermath, we could think of medical physics as one of the priorities. We could develop biomaterials from ceramics, plastics, glass, living cells, and tissues which can be re-engineered as coatings, fibers, films, foams, and fabrics for use in products and devices. Some of the applications could be heart valves, hip joint replacements, dental implants, or contact lenses. They are often biodegradable, and some are bioabsorbable, which implies that they are eliminated gradually from the body after fulfilling a function. For example, bioabsorbable zinc stent dissolves over time minimizing the normal chronic risks associated with permanent stents. Early testing with observable zinc stents have been promising. We have contributed much, and now it is time to think of road less traveled. Perhaps we need a paradigm shift from conducting research for the sake of research or as a knowledge quest to people-centered and need-based research that would enrich our future along with the environment. Wish you all the best for deliberations that would be helpful to the globe. Thanks for the invitation and for your listening.
Thank you so much, Father, for your innovative keynote address. And definitely your speech focused us into the theme and tone of this seminar. As you pointed out clearly, how challenges becomes opportunities in the area of multidisciplinary research, which should be used for the society cause. Thank you, Father. Thank you so much. Now, if you have any doubts or clarifications, you can ask Father. Participants, if you have any doubts, clarification regarding the keynote address, you can ask Father.
You can interact lively. Okay. Anybody?
Thank you, Father. Thank you so much for your speech. Thank you, Father.
Thank you. All the best.
So it's time for a tea break. All of you should assemble here sharply 15 minutes. So you can take 15 minutes, right? Then on a common instruction. So thumbs up using washrooms. Okay. So ladies and ladies staff, you can use the ground door, right? So just opposite this door.
Recording stopped.
That is women restroom. Okay, like that you can use. Then gents. Okay, you can use first floor, right? So first floor that you can use. Right. Thank you.
எல்லாமே டிஸ்ப்ளே ஆகுது வரும். இப்ப பாருங்க. ஹலோ, ஆடிபிள்? ஹலோ ஹலோ ஹலோ.
Yes, sir, audible, sir. Vijay, sir, audible.
யா, ஆடிபிளா?
Yes, sir, audible.
இப்ப என்னுடைய பவர் பாயிண்ட் ஓபன் பண்ணட்டுமா?
Yes, sir, yes, sir.
இப்ப பாருங்க, ஃபுல் ஸ்கிரீன் வந்துருச்சுங்களா?
Yeah, yes, sir, visible, sir, visible. Sir, we can start after the introduction, sir. Okay.
சார், என்னுடைய ஸ்கிரீன் மூவ் ஆகுதான்னு பாருங்க.
Yeah, yes, sir, screen is visible.
இல்ல, மூவ் ஆகுதான்னு பாருங்க.
Yeah, yes, sir, it's move.
மூவ் ஆகுதா?
Yeah, sir, move, sir. Yes, sir, super, move.
ஓகே, ஆரம்பிக்கலாமா?
Wait, sir. Introduction after the demo starts. Just wait.
Recording in progress.
To begin with, I call upon Dr. Rajit, the Assistant Professor of Physics, to give you a brief introduction about Dr. A. Vijayan, Senior Scientist, CSAR, LPL.
Zoom pen பண்ணிக்கோ.
Okay, everyone. So, I'll introduce our first person for this session, Dr. A. Vijayan, the principal scientist and associate professor, that is APL, CSR campus, New Delhi. Now, he is sitting in New Delhi. So, this session will be through online mode. So, his research area is about material science. So, particularly, that is growing variety of crystals and synthesizing various particles. He has completed his PhD this year, 2005, in University of Chennai. Then, followed by he has completed his studies.
மேல போறேன். உங்களுக்கு போன ஜாப் போறோம். சொல்லுங்க.
He has joined in LPL, that is New Delhi, 2004 as a junior. In 2007, he was promoted as scientist. Then, in 2001, he has promoted as senior scientist. Then, in the year 2015, he has promoted as a principal scientist. He is working now. Then, he has published various papers in SCA, that is Science Scientist Index journals. He has published 201 journals. Then, book chapters he has published, that is 5. So, totally his publication is about 391. Then, he has received various awards. I have highlighted some awards from the year, that is 2014. That is the year 2014, he has awarded the Bharat Excellence Award. Then, the year 2015, he has awarded that is Outstanding Researcher and Scholar Icon. Then, in the year that is 2018, he has awarded Dr. S. Rashegaran Award in the area of spectroscopy. Then, in the year 2020, he has awarded that is Raman Research Fellowship. Then, followed by that he has contributed many research papers. Then, he has visited many countries related to his research aspects. Then, he is a lifetime member of that is a Fellowship of Academic Science, Chennai. Then, similarly, lifetime member of Indian Laser Association, then Indian Association of Restaurant, etc. Then mainly there is is a principal investigator in the observer. It is given accurate 32.55 crores of funds. Now still he is working in National Physical Laboratory, CSR campus, that is New Delhi. So I would like to welcome Dr. N. sir to conduct this session. So welcome, sir.
Yes, sir. Yeah.
You can continue, sir. Thank you.
I am audible to you.
Yes, sir. Yes, sir. Audible, sir. You can continue.
Okay. Yeah. So, good morning to everyone. அனைவருக்கும் காலை வணக்கம். So, before going to my detailed presentation, first I would like to thank the conference organizers and the principal of the esteemed institution for giving the opportunity. I hope this is the correct time they organized. Yesterday, we have celebrated the National Science Day. And today, they are organizing the international conference. And we know that National Science Day, we are celebrating throughout our country for the celebration of our esteemed scientist, Sir C.V. Raman. He got the Nobel Prize and he discovered the Raman effect in the year 1928, 28th February. For this purpose, he got the Nobel Prize in 1930. So every year we are celebrating the National Science Day. See, by focusing that theme, they are celebrating the international conference. I am congratulating the organizers and the principal, organizer, convener of this international conference. Before going to my detailed presentation, first we have to understand. So for getting the good bandwidth, I am switching off my video. Nowadays, why we are doing different types of research work in different sectors of our daily life? You know, our Indian population itself, it is approximately 160 crores. If you calculate the overall population all over the world, it is approximately 700 crores. Each and every country, depending upon their geographical location, they need some advanced equipments in order to satisfy the general citizens' requirement. Whenever we are seeing about the science, always our focus is mainly focused on the research. But whenever you are in general term, if you see the science should give the solution for the problems what we are facing nowadays. That means the general citizens. Science is not having the geographical specific. Science is not having the language specific. Science is not having the regional specific. Science should give the solution for the problems the general citizens they are facing. That's what I have given my title, that technology transfer, academic research and then technology transfer. From that, we can able to improve our science and technology in an abundant way. So that is my main focus, what I am going to discuss today. My name is Dr. N. Vijayan, working as a principal scientist in National Physical Laboratory. So first, you have to understand what is the role of National Physical Laboratory. Then I will give you detailed information about the current topic. So National Physical Laboratory is one of the laboratories under CSIR, Council of Scientific and Industrial Research. In CSIR, all over India, we are having almost 38 laboratories. Each and every laboratory, they are focusing different theme of societal research. Particularly our National Physical Laboratory, we are concentrating for the development of science and technology through precise measurement. Few decades before, our Indian Parliament has given the status that National Physical Laboratory is the only institute is going to maintain the national measurement system. They used to call that National Measurement Institute of India. Each and every country in the world, they are having one National Measurement Institute. For example, in US, we can call that as the National Institute of Standards, NIST USA. Similarly, in NMI Japan, National Measurement Institute of Japan, that is the only one institute in Japan. Similarly, in India, we are having only one National Measurement Institute, that is National Physical Laboratory. Nowadays, pandemic period is going on. So whenever the pandemic period is over, I am requesting all the participants, if you are having the chance in the future, you can come and then visit our National Physical Laboratory. So in National Physical Laboratory, we are maintaining the all 7 basic SI units primary standards. I hope all the research scholars or the college students, they know what are all the 7 basic SI units. All the basic 7 SI units primary standards are maintained by National Physical Laboratory. In addition to that, we are doing our basic research also. So this is our front view of National Physical Laboratory. It is a very beautiful campus. It is located almost to the heart of the capital. So whenever in the future, if you are planning to visit, you can let me know, then we will have a visit for the educational purpose. So in the National Physical Laboratory, whenever I am telling about the research work, what all the basic research work is going on, we are encouraging the students communities to do their project work. For example, like MSc students or MTech students, if they want to do their part of their curriculum project work, you are always welcome. We have to follow some protocol. In addition to that, if research scholars or the faculty members, if they want to get some exposure in the National Laboratory, you can apply through some summer research fellowship program. It is every year given by INSA and then other agencies, Indian National Science Academy. Every year they used to give the advertisement in the month of December. So they are giving fellowship almost 3 months period. You can come and then you can learn the advanced equipments and then advanced instruments. So for what are all the equipments, what are all the informations regarding the basic research work, you can go and then you can see the informations in the given website, www.nplindia.org. In addition to that, I wish to give the brief information regarding the National Physical Laboratory. So when I was explaining the 7 basic SI units, we know that yes, distance is meter, weight is kilogram, time is second, like that 7 basic SI units are there. We studied in our college days or in the school days. But we never ever recognized that what are all the values of those 7 basic SI units. It is very difficult to imagine our daily life without the 7 basic SI units. For example, you are wearing a shirt, you are wearing a pant, it is having some certain measurement. Whenever you are waking up in the morning, it is having some particular time. You are walking, it is again covered with the distance. Like that, now you can open your textbook and then you can see all the 7 basic SI units. You can correlate your all 7 basic SI units with your daily life. Without a single unit, you can't able to pass a single day. All the 7 basic SI units primary standards are maintained by National Physical Laboratory. In addition to that, Indian Standard Time, IST, is maintained by National Physical Laboratory. We are the custodian, we are the timekeeper of our nation. You know, Indian Standard Time is very important in different sectors of our daily life. For example, nowadays you are doing the digital transaction. Maybe you are using your debit card or credit card or online transaction. And IST is playing a very important role. In addition to that, Indian Space Research Organization, we are sending the satellites, and NPL is having MOU with the ISRO because IST is playing an important role for sending our satellites. In addition to that, we are having MOUs with our Indian Air Force and Indian Railways and the civil aviation sectors also. So IST is having that much very important role for our daily life in different sectors. And in addition to that, other basic six basic SI units, it is having lot of applications in different research oriented activities. So that much important work is going on in National Physical Laboratory. And every year, National Physical Laboratory is open for the general public in the month of September. Sometimes in the 28th, 26th, almost at the last week of September, we used to open for the National Physical Laboratory for the general citizens visit. Even school students, college students, they can able to come and then they can able to see what all the research work is going on for the general societal purpose. See, always I am giving the series of talk. Yesterday I was in Haryana. I have gone there and then I have given a talk. Nowadays, what are all my focus and the theme of my talk is societal based research. See, for example, earlier I mentioned that our Indian total population is approximately 160 crores. Daily, we are facing some issues regarding our daily purpose. See, for example, whenever you are going out of your house, whenever you are standing in your street, you can see what all the general citizens are facing. Some below poverty line persons are there. They are not having the proper shelters. Even below poverty line, they are not having the proper drinking water. Even some of the small villages, they are not having the proper roads. Like that, n number of issues are there. Even in the metropolitan cities, instead of going water in the drainage system, it is coming out. We are not having the proper solution. For the cleaning, still we are using the humans. N number of problems are there. Earlier, I have clearly mentioned that science should give the solution for the problems what we are facing now. It is not meaning that we are publishing the papers and we are completing our PhD. We are attending some conferences and then we are submitting some abstracts and then we are completing our master's work or other project related work. And whenever we are doing any work, at least from that, we have to get some outcome for our society. Simplest example I am telling you, yesterday we have celebrated the National Science Day. We know that 28th February 1928, Sir C.V. Raman, he discovered the Raman effect. And we are all very proud. He got the Nobel Prize in 1930. He is an Indian. He discovered the effect in India. He designed the instrument in India. The total cost of the equipment is, you can't able to imagine, less than 500 rupees. It is still available in IACS Kolkata. They are keeping in a museum. Indian Association of Cultivation of Sciences, Kolkata. But whenever we are seeing these informations, we are getting very proud. And if you see the reality, Raman's effect discovered in India, he designed the equipment in India, but now the Raman spectrometer we are purchasing from Germany and then Japan. If you take the total population of their country, it is less than 10 crores. But in our country, we are having rich human resources, rich natural resources. That's what our Honorable Prime Minister always insisting that instead of depending on other countries, we have to make our own system, self-reliant India, Atmanirbhar Bharat. So we have to at least focus. See, we are celebrating 75th year of independence, 1947, 2022. Azadi Mahotsav. All these things we are telling, but till date, even a small pin to advance the equipments we are purchasing from abroad. So we have to focus in this direction. At least we have to start from the Raman spectrometer. Raman effect discovered in India, Raman spectrometer, at least it should manufacture from India. What they are doing, other countries, just they are making and then they are closing the box and then they are selling crores of rupees. Every year we are spending more than thousands and then lakhs of crores for purchasing the advanced equipments. So we have to focus, and at least our research should focus for the societal development, for the nation's development. If everybody involved, then you can imagine our India's GDP will improve a lot. Whenever we are talking about our Indians science and technology, we used to compare with other nations. We used to compare with Russia. We used to compare with US. We used to compare with other Western countries. They are all the developed countries. India is still a developing country. Whenever we are seeing what is the secrecy in the developed stage and then developing stage, when you analyze thoroughly as a academician, as a researcher, you can able to know that it is nothing. What they are doing, they are gaining the knowledge. We are also gaining the knowledge. But they are making knowledge into wealth. But our knowledge is still in the library stage only. What is knowledge into wealth and what is knowledge into library? Simplest example I am telling you. They are gaining the knowledge. They are doing research work. They are also publishing the papers. But whatever we are seeing the equipments in your house, you can take the television, you can take your cell phone, you can take your refrigerator, you can take your air conditioner, but that are all the research outcomes, but they are making money from that. That's what knowledge into wealth. But in our place, what is happening? We are not making knowledge into wealth. We are making knowledge that is in the stage of library to library. What is library to library? As a research scholar, I am joining under some supervisor, and he suggested to go and then search some literatures. I have gone to library. I found a few theses. I found some literature report. Then I myself, I attempted for making some new compounds. I made some new compounds, and my turn is over. Almost 4 or 5 years I completed, and again I am publishing, and again that is in the foreign journals, and finally I am completing my PhD, and again my PhD thesis, again it is displayed in the library. What all the gain of knowledge I have taken from the library, again it is in the library only. Again my next junior will come, he will also gain the knowledge from the library, and again he will make the thesis in the library. What are all the outcomes from that? What are all the outcomes for making the device? So that's what we are not able to go for the developed stage. So at least now we have to focus our research. We have to focus our knowledge. We have to make some wealth. That wealth definitely, it will boost our Indian economy. Not only a single, you can imagine all over India, every year, MSc students itself, MSc physics, MSc chemistry, or MSc biotechnology, or whatever it is. MSc students, rough data I am telling, 15 lakh students, they are submitting their project report. 15 lakh. I am not calculating the MTech and then ME. If you imagine all over, it is roughly 50 lakhs. You can imagine 50 lakhs of students, they are submitting the project report. If one student is taking one societal related problems, we are getting 50 lakhs of solution. One student is making how to conserve the water. One student is making how to conserve the electricity. One student is making how to convert electronic e-waste into useful product. One student is making plastic waste into useful product. These are all the things we need now, solution. We will get every year 50 lakhs of solutions. You can imagine. In that 50 lakhs of solutions, at least 25 lakh we can go for the technology transfer. In the 25 lakhs of technology transfer, you can imagine again another, you can divide it by 2, at least 12 lakhs. You can leave 2 lakhs also. 10 lakhs of small industries we can able to open. In the 10 lakhs of small industries, you can imagine 10 lakhs of entrepreneurs will be there. 10 lakhs of entrepreneurs, they will give at least 5 employment. 10 lakhs multiply by 5, at least 50 lakhs employment generation will be there. 50 lakhs of family, they will get benefit. From that, again, it will multiply. This is the simplest calculation I am telling you. These many advantages are there, but till date, we are making our research work in the library to library stage. At least from now onwards, the youngsters, we have to take as the initiative. At least we have to focus. We have to make our own products. If you go and then see in your house, television, foreign company make. Cell phone, foreign company make. Your laptop, foreign company make. Your tablet, again, foreign company make. Your refrigerator is foreign company make. For example, one person is earning 100 rupees. He is spending at least more than 90 rupees for purchasing these items. I am audible to you? Hello? Yeah. You can imagine, simplest example is 100 rupees one person is purchasing. He is spending more than 90 rupees for spending this, and then all the money what we have earned all are going out. So now we have to focus from academic research into technology transfer. Whenever we are seeing the problems what we are facing outside the society, we always blame our government. We always blame our politicians. Simplest example is plastic waste. Maybe in your house, you are making very neat and clean. And whenever you are seeing outside of your house on the street, you are seeing lot of plastic waste. Whenever we are seeing the plastic waste, we used to immediately blame politicians or the government or the system. Always, we never ever accept our fault. So the blame game will start. Whenever you are seeing the plastic, it is not the politician's fault. It is not the government fault. It is not the system fault. It is the fault of the academicians. It is the fault of the researchers. We have to take the blame. I have to take the blame. Who invented the plastic? We never ever blame the general citizens because they are all the end users. What are all the product you are giving, they will use. If you are giving good product, it will be good for the our earth. If you are giving some product and it is giving again bad effect after some time, then we have to take the blame. The plastic, whenever we are seeing outside, every year or every day, it is piling up thousands of tons all over the world. Even we are thinking that we are eating clean water, we are drinking. We are thinking that we are taking clean table salt. We are thinking that we are eating good sea animals product. Even we are thinking that we are taking clean cattle's product, that means milk and other things. But recent study saying that even your table salt contains microplastics. Recent study is showing that all the fish and then other related products of it is coming out from the sea, it contains the plastic. Then how to control? See, now we are talking about the many informations. We are talking about the plastic recycling. We are talking about the through plastic waste we can able to make plastic roads. But at the same time, it is gone beyond our hand. when we are giving some product to the general citizens, we have to see what all the side effects will come in the future. Before that, we have to give at least some solutions. So these are all the things I am going to discuss. So some of the slides I made it as Tamil also. What I have mentioned in this science. Science is nothing but it should give you a solution for the problems what you are facing. What I am facing, I am not having the proper drinking water. One bottle of drinking water, they are selling 50 rupees outside. But is it really affordable? If you are a middle class, you can say that yes, I can able to purchase. But the science should be equal for everyone. Below poverty line, they can't able to afford 1 liter of water equal to 50 rupees. But that is your prime responsibility. We are all educated. We are all academicians and then researchers. If you go and then see the general citizens, they are paying the tax. They are giving responsibility to us. They are not asking the salary from us. They are asking at least to give some solutions. If you are not able to do, then who will do? If you are making dirty water into a potable drinking water with the cost of 50 paise per liter, that is called the societal research. That type of research only we need now. And who says that whenever you are working for the societal problems, paper we can't able to publish? You can able to publish. Which journal they will not accept? All the journals they will accept. If you are having some novel idea for making dirty water into drinkable water with the cost of 50 paise per liter, all papers, all the journals, even Nature also they will accept. So if you are having some idea in mind that if we are working for the societal based research, we are not able to publish the papers. So that is the wrong concept. I am not saying that you have to work only for the drinking water. What are all the research work you are at present you are carrying out? From that outcome, if you are finding some, if you are correlating some solutions for the general society, that is the research you have carried out for your whole life. At least throughout our life, 1 or 2 products. If everybody of our researcher in our nation thinks, then it is not necessary to depend the other countries. That is called the self-reliance. That is called the Atmanirbhar. That is the thing the government is encouraging. Yes, there is no wrong in that. If each and everybody of our researcher community, if they are working, then that is really excellent. Then India, nobody can beat. You can go and then see in our roads filled with foreign cars. If you go and then see the products in our house, all are made in abroad. Our total population is 160. We are purchasing the products. It is less than 10 crores of those countries. You know, in our 160, 150 to 160 crores of Indians, less than 40 years of age, 45 crores. Less than 40 years of age, it is 4 times of Japan. At least 5 to 6 times of Germany. But why we have to depend other countries? We are having all the rich natural resources. Whenever I used to give the talk, I used to mention that nature has given free of cost water. Nature has given free of cost oxygen. Nature has given free of cost energy. But we never ever give respect for getting free. Water is given as a free of cost by the nature, but we are purchasing the water almost 50 rupees. 50% of the cost of 1 liter of petrol. Nearly 30-40 years back, nobody thought of water will be selling in this shop, but it became reality now. If you go and then see all the shop, they are selling the waters. If we are doing our research like this, then one day they will be selling even the basic need of oxygen also by packed bottles, packed cans. So we have to be very, very careful. National Physical Laboratory, I clearly mentioned that it is the National Measurement Institute of India. During those days, you know, the first founding director of National Physical Laboratory is Dr. K.S. Krishnan. He belongs to Tirunelveli. He was the first student of Dr. Sir C.V. Raman. He has written series of papers in the Nature, and he categorically mentioned that what is the role of National Physical Laboratory. But still, we are going in the same path what he has shown earlier. And earlier I have mentioned that NPL is the timekeeper of the nation. And in addition to that, we are maintaining all the 7 basic SI units primary standards. And some of the products from NPL, even indelible ink, Election Commission of India, they are using for the democracy of mark of democracy. It was developed by CSIR, National Physical Laboratory. You know that the original Constitution of India, it is still in the Parliament House. It is preserved by CSIR, National Physical Laboratory. And you know, this is a very good photograph of a group of students of Dr. Sir C.V. Raman. They have done wonderful work. Those days, that time they have not that much developed. We are those days, no internet, no basic facilities. Now we are having everything. But we are not able to contribute that much now what they have done earlier. He got the Nobel Prize from India 1930. 2030 is going to come, another 100 years. We are not able to get the Nobel Prize. So at least we have to change this scenario. So this is the Raman, Sir C.V. Raman handwriting, because yesterday we have celebrated the National Science Day. I thought of including this. Sir C.V. Raman, he himself, he has written what are all the observation he has found from the Raman effect, light scattering. You can see his group of students. This is the simplest instrument he has designed. It is available in the IACS Kolkata. Discovered in India, discovered by an Indian, but now Raman spectrometer we are purchasing from Germany. I used to show this. I like this as a crystal grower. He is keeping excellent ammonium dihydrogen phosphate single crystal. You can see. We are living. We have to live along with the nature. We should not destroy. Nature has given everything for our needs, not for our greeds. The greeds are the responsible for spoiling the environment. What sin they have done? Sea animals. They started eating the plastic. Seahorse started eating the plastic. Tortoise started eating the plastic. N number of animals, they started eating the plastic. But plastic was produced by the humans. We have not given the solution. You can see, this is not the road. This is the canal filled with the plastic. Everywhere plastic. At least the general citizens, they are expecting, you are all the educated personalities. You are all the academicians. You are all the researchers. You can give some solution for this. They never ever ask anything from that. Government is also not asking. Government is giving. Government is supporting for your education. Government is giving everything. Government is not asking back that whatever salary you are getting, you can give it back. They are asking, you can give some solution for this. They are asking, you can tell some solutions. We can make our own rules and regulations. At least we can think in this direction. See, nature has given abundant water, purified water, but we ourselves, we are destroying the water. And after some time, we are purchasing the water also. So it is like a reverse process. Again, nature has given free of cost oxygen. If it is going like this, then soon you can able to see all the small petty shops. They are going to sell the oxygen cylinders. What are all the other things we can able to focus? It is not necessary to go and then sit in your library. You can see the general citizens, what they are facing. They are not having the proper houses. They are not having the proper electricity. They are not having proper recycling system. Even nowadays, electronic gadgets usage is more. Cell phone, computer, laptop, many things are there. But we are not having the proper recycling policy. You can see concrete. Sometimes we are demolishing our building and we are throwing that concrete waste to the other street. But anyway, it is one way we are destroying our mother earth. We are not having the proper system for this. So these are all the things we can able to focus. If you are not able to do, then who will do? I am going to give you a simplest example. Everybody knows about the Stephen Hawking. He is no more, but the persons you are not aware of the Stephen Hawking, just you can type in the Google. He can't able to walk. He can't able to speak. He can't able to write, but he has done wonders in the science. Till date, his one of the books he was published earlier. It is the top sellers book till date also. Nobody can beat. The Brief History of Time. So he has done wonderful. He has given everything. But you can see overall, we are all the end users. Somebody has inventing, we are using. But this is your prime responsibility. This is our prime responsibility to give something for the next generation. How you are using a laptop, cell phone, computer, television? Because our forefathers, they have done something we are using. They have done their duty. If we are doing our duty, then only the next generation they will enjoy. At least we should not pollute our mother earth, and at least we have to live for the next generation. So these are all the things you can see. These many things are there for focusing: automobile and transportation, waste recycling, renewable energy sources, new materials, societal based products, artificial intelligence. You can add n number of things. You can find out the solution. So that is called the science. But earlier I have clearly mentioned that technology transfer is missing from our academic research, from our research. What we are getting the outcome. That is only in the library to library stage. We have to move forward from library to at least some device. So these things we have to go for the technology transfer. Whenever we are going for the technology transfer, automatically number of entrepreneurs will increase. They will start their own industries. It is always not necessary to depend on the government. Government is giving the job. We have to make our own job. We can able to give at least 10%. Under us, we can able to give employment of 10%. You can imagine, at least all the academicians, if we start this revolution, then it is unimaginable. Technology transfer. It is still in the academic research. We have to move forward for the technology transfer. We have to give it that technology for some industries, small industries. Simplest example I am giving you, your kitchen water is also going in the drainage system. Your washroom water is also going in the drainage system. Kitchen water, what is there? Only you are washing your vegetables. You are washing only your vessels. That water you can able to recycle it. Again, you can able to lift that water to your tank after recycling, but still we are not having the technology. We are having abundant sea water. We can able to make the drinking water. We are having abundant natural resources. We are getting proper rain, but we can't able to save that rainwater. So these are all the few things at least we can move forward. Definitely we can able to achieve in a cumulative way. At least from the research and development, we have to commercialize the product. That's what knowledge into wealth, knowledge into library. So many things are there. You can see computer, the initial invention of the computer itself, it occupied the size of your hall where you are sitting in the today's conference. One system occupies, but now it is very small. Small gadgets started coming. That is also the advanced research. You can see vacuum tube technology to the integrated circuit. The first generation of the computer, we are talking now 7th, 8th generation. Many advanced systems are started coming. So in NPL, in particularly our division, we are working the reference materials. What is reference material? What is metrology? First, you have to understand. Meteorology is different, metrology is different. Meteorology means weather related informations. What is metrology? Metrology is the science of measurement. What is the science of measurement? For example, you are feeling that you are having tired continuously. Whenever you are discussing with the doctor, he used to go for the first take the blood glucose level. You have gone to Tirunelveli. You have gone 3-4 places in the Tirunelveli. You have given your blood. Evening you are going and collecting the data. If you compare all the 3 results of the same person blood, you are getting 3-4 types of results. If you measure your BP, blood pressure in 3-4 places, again you are getting 3-4 types of blood pressure. Person is same. How? Because our scientific equipments is not properly calibrated. What are all the effects? If you show this result, then doctor suggests that no, you are having high sugar, blood sugar level, then you can take medicines. It's a great surprise that if the person is not having the blood sugar, if he started taking the tablet, it will affect the other organs of your body. Still the same condition is going on in our place. Not only medical equipments, in our research equipments also. One sample, if you give for 3-4 places for the powder XRD, you are getting 3-4 types of results. If you compare all the 4 results, the first peak in somewhere it is appearing 20, in some other result it is appearing at 22. Which is right? That's what we have to focus. Metrology. Metrology is the science of measurement. 20 degree 2 theta value, the first peak has to appear, it has to appear at 20 only. Why it is shifting to 22? Then many of the papers, they are reporting the wrong data. So finally, our scientific ethics, we are not properly following. So we have to focus in this also. For that purpose, NPL is rigorously working for the making reference material for the advanced equipments. So it is having a lot of advantages. You can see, I am the company owner. I got the order from abroad, almost 100 crores. They asked me to make one small scale, 30 centimeter precise. I made the scale. I packed my scale. My consignment is ready. I have sent to abroad. That finally, they have measured my scale. Instead of 30 centimeter, my scale is only 29.5 centimeter. My consignment came back. What all the investment I have done, 100 crores is gone waste. What all the manpower I have invested, all gone waste. What all the income that is in the form of tax, it has to come for the government, all are gone waste. Because my measurement is not correct. So measurement, not only your scientific research, measurement is very important for the industrial development. Measurement is very important for your health sector. Measurement is very important for the environment. So all the sectors, if you see, measurement is playing an important role. Meter, kilometer, second, the units, all are interrelated. That's what earlier I have clearly mentioned that without the 7 basic SI units, you can't be able to pass a single day in your life. So I mentioned reference material. In Hindi, they used to call us the Bharatiya Nirdeshak. So our division is actively engaged for making different types of reference material. Through this, we are giving technology transfer to the industries. We are encouraging the MSME sectors. Through that, we can able to get the financial support, markets, technology. If we maintain the properly 7 basic SI units, if one person understand about the metrology, he can able to do science in a scientific manner. Technology perfect. You can see n number of applications. Every year, all the national measurement institutes, they used to celebrate the International Metrology Day, that is World Metrology Day, 20th May, every year. Every year, from at least now onwards, you can see what are all the themes they are giving. In 2020, they have given the theme that measurement for global trade. You can see for doing your business international level, you need a proper measurement. 2021, they have given measurement for affordable health sector, affordable health care. If you are having proper measurement, then you can able to afford your health. That means health sectors of different medical institutes. This year also they will give, you can able to see 20th May, every year they are celebrating, and NPL is also celebrating. Our Honorable Prime Minister of India, and he dedicated to the national, Indian reference material, that is Bharatiya Nirdeshik Dravya, to nation in the last year. You can see this is our Indian reference material wing for preparation of different materials. So I don't want to take more time because some of the other presenters are ready. So if you are having any questions, so I can able to answer your queries to the best of my knowledge. So once again, I am thanking the conference organizers for giving the excellent chance. Anyway, I thought of coming there, and then due to pandemic and then other commitments, I can't able to come. I hope now you can understand the value of your research, what you are doing. At least my request is, yesterday we have celebrated the Science Day. At least now onwards, today is the 1st March, we can take the self-worth that I can do something for the society. So once again, thank you very much. Hello. I am audible to you. Hello. Madam. Hello. I am not able to hear your voice. My voice is clear. No answer from your side.
Hello, sir. Audible?
Yeah. Now only audible. Yeah.
Vijay, I am the next speaker from Botany Department, retired professor of Botany Department, same college. I appreciate for your workful, thoughtful, and encouraging talk. The same concept is also with me. That is the real creative research in India. Depicted. I am very sorry. I know from your talk, and I am happy to say I am also a senior research associate. I was working in the Bharat University in the biotechnology department and a senior research associate of CSI. Okay, sir, thank you very much. I am also very into the act of creative research in India. So I am also going to give the lecture in the same environment. Thank you very much, sir.
Thank you, sir. Thank you very much.
Participants, any more questions?
Sir,
Yes, ma'am. Yeah.
there is any applications for silver buttons, any extra conversations, please. Kindly please give me suggestions.
Madam, yeah, but I am getting some voice, but your voice is not clear. Maybe somebody can tell what madam is asking the question clearly, because I am not getting voice clearly.
Okay, sir. Sir, can you hear me?
Yes, ma'am. Yeah, your voice is coming, but it is like echo. Can you type what are the questions in the chat box? I will read and then I will give the answer. Anybody can type? The organizers?
So actually, ma'am is asking the more applications of nanoparticles are similarly the research areas we can focus in terms of nanomaterials. The more application oriented the nanomaterials, what kind of studies we can do? That is the questions from participants.
Sir, I am sorry again because I am not able to get the voice, your voice as well as madam voice some echo is coming. So can you type what your question is? I can able to give the answer because some echo is also coming along with the voice. Can you type? Anybody can type? Organizers?
Yes, sir. I can type it, sir. Sir, now it is audible what I'm speaking.
Yeah, but I am waiting in the chat box, but there is no chat. Otherwise, if you are having any questions, so I will wait some more time. But still, if you are having any questions, that's what in my first slide, she is asking how to make the silver particles, right?
Yeah, yes, sir. Yes, sir. Yes, sir.
Yeah. So silver particle, in which method you want to make? You want to make it in nanotechnology process, or there are different methods are there? Insights to product of low cost materials. Low cost material for making the silver particles. Nano. Okay. So in that, yeah. In that case, there are different methods are there. So you can able to make. How can we reach you? Please provide the contact details. Yeah. In my first slide itself, I have given all my contact details, my phone number, and then my email ID. If you need any of the research scholars needs any help, so to the best of my knowledge, and then with the available facility of myself, what all the facilities in my group it is there, definitely we can able to share the informations. In addition to that, if the facility is not there, I can able to say that this facility is available in that particular institute. Like that information also I can able to give. Particularly for making the nanoparticles, silver nanoparticles, there are different techniques are available. So nowadays they are making through some green synthesis process. Somebody is making through some different chemical routes. So depending upon your opt method, you can able to choose that. So if you need still some more information, I can able to share through email.
Okay, thank you, sir. One more question from the audience. Sir, can you mention the career opportunity in NPL? How we can enter into the NPL? Is there any?
See, from your voice, I can able to understand. It's still not clear. That's what always better you can put it in the chat box. See, what I understood. What I understood is you need what are all the process to come to NPL for the analysis. See, there are some informations they have given in our NPL website. One is outreach. There are two categories. One is for the industrial users that the charges are separate. Another one is for the educational institutions that equipment charges are separate. You can go to our NPL website. You can see samples for characterize, sample to characterize. You can click that area. They have given number of equipments, instruments to be used for our experimental work. So you can see which equipment is suitable, which instrument is suitable for your analysis. You can choose. In addition to that, if you are not able to pay that money, maybe the particular user, they can contact directly the equipment in charge. You can say that we can't able to give that much charges. We are not having any project work. So under his capacity, after getting his, maybe he will get approval from the higher authorities. So definitely he can able to support for your characterization work. Regarding how to enter into NPL, there are different ways are there. One is if you wish to do your project work for the MTech, ME or MSc students, first of all, you can go to our NPL website. You can see what are all the research areas, whether it is really suiting for you. You can go through that. If it is really yes, there is one separate column is there, that is HRD, Human Resource Development. There you can go, there is some particular form is there, you can fill it, and then after getting your approval from your institute, you can send it to them. In addition to that, for the PhD as well as BSc, MSc, ME students, nowadays every year INSA, Indian National Science Academy, they are giving the summer research fellowship. It used to come in the month of December, January. You can apply. If you get selected, then directly you can choose NPL. NPL name is there, and then my name, and then other researchers' name. Already they have displayed in that website. You can choose. They will give your financial support for 3 months stay, your transport, even your fellowship, and some other contingency amount also they will give. That will be a very good opportunity for you. Any other questions after this?
No, sir. Thank you, sir. Thank you for your valuable points. Your talk was particularly appropriate at this time. So we are considering a new initiatives for expanding growth. Your talk was really nice and wonderful. We could learn many things from your topic. So, moreover, I want to convey one thing, sir. In our international conference, we could see the content growth comment. That is really amazing one. So, our heartfelt thanks to you. Thank you, sir. Thank you again, sir.
Yeah. So once again, thank you very much for wonderful opportunity you have given. So again, I am thanking the organizers for giving the excellent chance. So wish you all the best, all the researchers. So once again, see you and then thank you very much.
Now I move to Galapan, our head of the department, Dr. Premanan, to introduce our resource person, Dr. Ravi Raj, former associate professor of botany, St. College, Coimbatore.
Very good morning, dear participants. You finished talking. So it is an international conference. So you should be very serious regarding this. Is it clear? Okay. So in this session, let me have the private privilege to introduce Dr. V. Giriraj. Dr. V. Giriraj is the research professor and associate professor in the Department of Botany at St. Xavier's College, Coimbatore. And he has a number of credentials ranging from fellowship to research papers. It goes on to pages. So, to just a few points, let me highlight what are his credentials. He did his BSc, MSc at College University, and PhD at St. Xavier's College, Coimbatore. And he was the first student of He was the first student of Dr. E.S. Mani, SJ, and he was also a postdoctoral research fellow at the CSCR Punjab University, Patiala, and he was the associate professor of botany from the year 2001 to 2018, and his area of specialization are pteridophytes, ecology, cytology, etc. And he has published more than 100 papers in leading national and international journals. Let me welcome Dr. Edila sir and let him present his findings.
Dear professors and my dear friends, and my dear students, I am very happy to stand this work. First of all, I thank the organizers, all the organizers, for giving me this opportunity to share my experience gained through my teaching, research, own research, and from literature. I shall Next. Material science, not only nanotechnology. So, what are these? The large one. Flower birds, nothing. Wax crystals on the rose petal. Wax crystals on the rose petal. Next. So, this is my personal laboratory in my home. After retirement, I am doing my research. Okay. As a physical scientist, I want to ask one question. Microscope, optical physics. So first one is compound microscope, compound light microscope. In which there will be one objective and one eyepiece or binocular. But in stereo microscope, there will be two objectives and two binocular eyepieces. What is the basic principle? Anyone know? Why there is single objective in compound microscope and double objective in stereo microscope? I have taught in my research project microscopy and other things. What is the reason? Our microscope only two-dimensional or three-dimensional. So, for example, two things. In the light, you cannot see the you use double light, you can see if I use two eyes, we can realize the three-dimensional image. For that purpose only, two objectives in three. That is the reason. So, what are materials? Materials are the substance of things. Material science interdisciplinary field in physics which concentrate on the structure properties of the materials that will lead the designing of our materials for engineering applications. So, materials have been created for use. Humans are created. Humans have been created for topic. Materials are created for use. But nowadays, reverse condition is concerned, ultimately causes several problems. Material should be properly used. Humans should be properly out. Physicists and material scientists are to use the materials in successful and sustainable way. Next. Third is the best materials. So that's all very good material science. You select particular material. So what are the major areas of material science? Energy production and storage, electronics and photonics, bioinspired materials and system, green technology. These are the four areas of material science. So pteridophytes fly in all these fields. I should give you the examples. Next. So material science, the earth, what are the sources of material for material science? The earth, non-living material, living material. Living organisms also contain several physical materials and mechanisms, but not properly investigated, used by material scientists, particularly in India. India's material resources. Next, classification of bionanomaterials, DNA, amyloid, fibrates, bacteriophages, minerals, viruses, enzymes, and nucleic acids. Next, on 2011, India ranked 6th globally in material science research. China is a leading country not only in material sciences but also in terminology. In our field also they are leading. Material science also they are leading. Indian scientists developed Earth's thinnest material with novelty. I have done. Indian scientists have done thinnest material. Next, IIT. Who is this man? Anyone know? Order Subramanian Viswanathan, also known as highly accomplished Indian material scientist and emeritus professor of IIT Madras. What is the peculiar similarity? He is also native of Kanjur district. I am also native of Kanjur district. The famous today famous Michael Patel. You might have heard Michael Patel. He is the native place of Mysore. So he is from just 30 kilometers to Kanjur. So I am biologist. He is physicist. Then another similarity. I am also Joseph. He is also Joseph. So what is the common? Next. So when I go through the science journal from India, I could not find any paper based on that, except a few papers on nanosynthesis of nanoparticle. What is it on green synthesis of nanoparticle? That's nothing else. Next. There are several gaps to be filled in biology by material science. There are a lot of gaps which should be filled by material science. See, human sperm. Sperm food biological is for 350 years. They are food as what using 3D microscopy and advanced mathematical and international team. Universities in England and Mexico discovered that science snake-like movement is an optical illusion. Not only they have confirmed. So for 350 years, we believe that they are swimming like a fish or snake. But it is an optical illusion. Then how does sperm move? By spinning, not swimming. By spinning, not by swimming. This kind of mechanism, 350 years, we believe from concept. They are spinning in a 3-dimensional. So physical materials and mechanisms in biology are ought to be unearthed and utilized. Next. So this is the living organism basically, the non-living part, cell wall, Passcode, etc. Non-living part. That's all living part. Next. As far as plants are concerned, about physical mechanisms and inner materials are available for material scientists from lower plant algae to higher plant flowering plant. Next. So this is what is it? Rescues in diatoms, phytoplankton. They have very important role in nanotechnology. So silicon diatom rescue as non-structure photoelectrode. Next. So diatoms, the most common type of phytoplankton found in nature, exhibit high solar energy harvesting efficiency. Due to that rescue, the hard porous cell wall made of silicon possessing remarkable hierarchical micro nanoscale features. Diatom. So there is a paper, silicon, diatom rescues are nanostructure with photoelectrode. Next. So see, compare both and building material by raising pillars, concrete pillars, line, On the side, tree, large gigantic tree, and on its own strength. What is the difference? How such a large tree standing erect without any pine rod and other things? How? What is the secret? So the strongest part of a tree lies in the cell wall. Cell wall component. In a brick and mortar pattern. 6 microstructure stops here. Crack from running straight through the middle. Next. So wood, hardwood, sapwood, hardwood, etc. The wood anatomy is very complicated. Next. See this. When there is wind force, the tree bends down. What will happen? On upper side, tension. Lower side, compression. How the tree will adjust? By forming reaction loop. Reaction. So when I was taking anatomy first, MSc class, I learned. So tension on the upper side, tension loop will form. That's the reaction. On the lower part, compression. What is the tension? There should be elasticity for that purpose. More and more cellulose will be deposited. On underside, to adjust the pressure, compression, more and more beginning material will be deposited. That is the difference forming reaction group. Compression and tension. So ultimately what will happen? Instead of forming symmetrical wood, they will form asymmetrical wood. What is the secret of asymmetrical wood? Higher fabrication of asymmetrical material for that liquid transport. That is the mention for asymmetrical wood. So even a piece of wood, fine wood, piece of if you fit on the tip of a tube, you can use it as a water. Good water to remove water, debris and other things. Natural water. So understanding the link between water and the cost of nanomaterials material. So cellulose, the most abundant organic compound, the most abundant biopolymer, the most abundant polysaccharide compound in the earth. So there is reason 2022 on cellulose. Printable classical nanocrystalline cellulose composite hierarchical and high upward on cellulose. How many of you know the secret code of function? For several factories in system model. We are exporting. We are exporting. So, work itself to produce activated carbon for several purposes. Next, the potential of coconut shells through pyrolysis technology is very. The products are in the form of carbon fiber, bio-oil, biogas fuels, etc. Next, preparation of thermally and chemically activated carbon from coconut shell and absorption studies for iron removal from drinking water. Next, so coconut shell carbon, granulated activated carbon, granulated activated carbon. Next. Then, what is such hardness? What is the secret? I am brought to speak the coconut. What is the secret? Even coconut could inspire new designs for earthquake-proof building. How? The arrangement of cellulose structure, cellulose structure, etc. Arrangement. So there is a distinct ladder-like design. Next, this combination of lightweight structuring with high energy dissipation capacity is of increasing interest to protect buildings against earthquakes. Next. Hierarchical. What is the secret? Even I searched several days, I could not find any anatomical study, internal structure study from India. No paper. Even from bodies, no paper. Then I found one paper. Hierarchical studies, structure of the corpus is from functional morphology and its influence on fracture muscles from I think Germany. Next. So they have explained a detailed structure, molecular, chemical, and ultrasound. Next. So what are these? Pasta, medical pasta, not pasta, but pista. So I am eating regularly. Each and every day when I use this edible pista, I will think what is the whole structure or there will no. He was thinking there should be something special secret on this food order or Indian by then only for this symposium I sent some literature. There are not many paper, only very few paper, some with some secret, including that in the sub number. So, structure, very fibrous structure with a combination of amorphous and crystalline polymers. Sets were found to have laminar polymer layers wound around pores. Chemistry made from triglycerides and cellulose with no trace of inorganic. Next. So, she has investigated the structure. Next. 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 So, see the ultrastructure. Just like a rock surface without any gap. Rocky surface. The pista structure. Next. So, green fabrication. Green fabrication of copper pistachio shell, nanocomposite using pistachio vira. An efficient catalyst for efficient reduction of core nitrophenol and organic dyes. So, pista, nanoparticles, users, next. So, next. So, what is the source of today's core thermal core? This will be known plant material. Millions of years ago, plant materials. They have found that. What are the group of plants? Only our favorite plant of the dangerous group for the today goal. That is this type of carboniferous forest were present only during carboniferous urban period, carboniferous period. Our favorite pteridophytes were the dominant plants during that period. By natural calamities, they have suffered. By submersion, they form peat, and under pressure and heat, they form lignite and coal. So, let us come to the technical. This is a small sized plant. We can see that at the margin of the leaf, the reproductive part. Sorry. The reproductive part, sorry. Sorry. So here, these are veins, normal veins. These veins combine join together to form a platform on which the reproductive structures, sporangia, veins, they form connecting bridge. So what is the secret? When I studied the anatomy, there are different cellular structure. Here one kind of cells, long, linear cell. Here scout cell, loosely arranged at the meridien. Then at the corpomedian, small sclerites, compactly arranged. So looking like a pillar. Next one. So see the pillar of a bridge and this firm structure. Whether man copied this principle or man principle. Looking like a pillar. This strong structure. Next. So this is a single splenic. Next. So this is another aquatic plant in the aquatic field, Orchidia minor, 4-leaf plant. So they will survive both under water. In water, the leaves are floating. In water, the leaves are freely floating on the surface of water. They need not have any special mechanism weight. But in terrestrial conditions, the leaves are floating in the atmosphere. They need special mechanical structure. So the same plant will produce a special mechanical cells under terrestrial conditions. Next one. So this is aquatic plant leaf. This is terrestrial plant leaf. See that special structure developed by tissue. What are these? Sclerites. That part. That matter only for support. Mechanical support. Single sclerite. So there is no study. There is nothing study on this that matter. Sclerite. What kind of cellulose material, what kind of chemical composition, strength, etc. Nothing. Next. So in the same plant, the reproductive part is also very good material. Reproductive part called a sporocarp, spore producing protein body. Next. Please. The existence of this fruit body, sporocarp is very interesting. Just physical mechanism. So there will be outermost hard wall. Next to the outermost layer, inner wall, there will be a gelatinous layer. Gelatinous layer, by absorbing water, it will bulge and exert pressure and the sporocarp decays. By throwing the gelatinous layer along with the sporangium. Gelatinous layer attached to the sporangium. Next. See the tension mechanism. Just by physical mechanism. Hydrophilic. Next. See this wonderful photo. What are these? The single spot, sorus, reproductive spot. What are these? This is the young stage. These are protective structures. Only that part. Just for physical protection called paraphysis. Along with the sporangium. At mature stage, sporangium and the paraphysis. In young stage, first paraphysis, the protective structure. There are no studies on such a non-living material. Paraphysis. Next. So these are fiddle gland with hairs, lot of hairs. Next. So this is also a field. Plants are usually covered by rhizome, underground stem will be covered by this is water scale rhizome with a lot of difference in structure, architecture, and cell composition, etc. There are no studies on it. Here as a botanist, we use such a difference for identification products. No detailed study on architecture and other chemical composition. Next one. So see this scale. Next. This is video. It's not repetition. Video is not repeat. What is physical mathematical point of view? What do we know? Burns are good example for fractal geometry. Fractal geometry. One by one repetition. Fractal geometry. Next. Why inspire the fractal electrode for over years? By inspiring variation model of a firm. So they have developed a super by inspiring fractal electrode by inspiring the variation pattern of firm. What is the will come. Next. Then another example for fractal geometry. Fractal physics. Melting heat transfer enhancement of a horizontal lateral heat storage unit by burn fractal fins. Next. See this. Fan fractal LH unit by copying fan fractal. See the difference between fan fractal film and conventional film. Next. Then this is another fan. Another fan on two applications nanotechnology will point out. Both hydrophobic and leophilic. Hydrophobic and leophilic. Next. See the fan leaf with hairs. This is the single hair, branched hair. Next. Super hydrophobic family. Super hydrophobic. Next.
எம்மையாற்றிலே ஈரக்காற்று கண்ணனோடுதானாட பார்வை புத்திட பாதை பார்த்திட பாவைராதையோ வாட யமுனை ஆற்றிலே ஈரக்காற்றிலே கண்ணனோடுதானாட.
Next, crude oil. Leophilic, they will attract, they will get the water, they will attract the oil. They have replaced it for oil cleaning purpose. One step fabrication of Sardinia hydrophobic surfaces with the light adhesion. Next. So, scientists, engineer and planner, they have done. Next. So, engineering plan. Next. Next. Firm version terrorist by modifying gene modification of the protein firm by inserting such protein in angiosperm, they have developed atomic bomb detector. Main thing from firm protein, they have modified the protein firm and inserted into the angiosperm beam to detect atomic bomb in the airport. When there is bomb, the burning will become white color. When you remove the atomic bomb, it will return to carbon beam. Next. Design fabrication in silico model. This paper they report that design fabrication and characterization of in silico cell physiology biotic for measuring calcium ion bond. Next. Spore saw. In spore saw, they have used the single spoke to measure the gravitational force, calcium ion concentration. Next. So single spoke. On both sides of the spoke, they are using electrode to measure calcium ion concentration from single cell. Single cell calcium ion concentration can be measured with such high sensitivity of the circuit span spoke. Next. This is another interesting bio-inspired. So based on the mechanism, scientists have developed the microactive for producing electricity. So what are these? Pores and non-living material. they are not DNA. They are non-living material called electrons for what purpose? To detect the parameter by hygroscopic movement. Electrons. So by hygroscopic movement, they will accept this oil and physical and only many species in that group. So it is called living fossil. The electrons will be coiled around when there is dry condition, and also the this way. And specifying band. Next. So there is a difference in composition between composition at the tip of electron and the surface area of the electron. Such a difference is the basic principle for such kind of hygroscopic movement. Next. So see there is different nanoparticle. Some spherical containers, silica amorphous provider, at the surface of electron. Tip surface, other surface, they are different in chemical composition. Next. This is another very untouched field. I am sure if anyone take research physical science, you may develop at least I think cost effective AC or machine, etc. But there are no study. What is painting? Ornamental painting? White line. Next, there are white lines. What are these? What is for ornamental purpose? No. They are for respiration. Respiration, particularly during the coiling. During that period, for aeration purpose, such structures are available. There are a lot of variety of structures in plants. Our favorite plants, where there is no detailed study. Aeration purpose, just physical mechanism. But there are no detailed study. Anatomical or physiological, there is no detailed study. Just I tried one simple experiment. I by nail polish, I go the line. Within few days, the leaf with the these are aerophone, called aerophone. That is street like structure. There are no study about except we have published one paper in one. Next. So morpho-anatomical studies on aerotic structures in blood organ valley. Next. Let us come to another. Biomineral proteomics. Biomineral. What are bio? Next. Cystodes. Three kinds of biomineral structure. Cystodes, idioblast, phytodes. Cystodes are made up of calcium carbonate. Idioblast, calcium oxalate. Phytodes, silicon. Next. Next. So, please carefully note this explanation. Still, even in my opinion, there are lot of scope and there is no detail at all. Even you can apply a major project. You might apply a major project. So please Carefully note this. This is a flower bud of ordinary breed, Sida acuta. Sida acuta. What is the outer cover? Green cover called sepal. Ali you talk to your own. Sepal, calyx, sepal. Next one. So flower with sepal. What is the secret? Here, this discovery, here friends, this discovery is of my own creative. This discovery on my own creative knowledge. நான் இதை தேடி ஆராய்ச்சி பண்ணேன். சொல்லப்படுற பாயிண்ட் தேடி ஆராய்ச்சி பண்ணேன். நான் இதுக்காக குரோமோசோம் ஸ்டடி, குரோமோசோம் கவுண்ட்காக அது புலவப்பட்ட நெசசிட்டி, அதோட ஆன்சர் ஸ்கோர் மதரசம் கோடன் மதரசம்ல வெளியே பண்ணி அதோட டெக்னிக்கல் பண்ணிட்டு செல்லும் கோடன் மதரசம்ல குரோமோசோம் ட்ரை பண்ணேன். ஆனா குரோமோசோம் ஆனா எங்க மாறிடுச்சு. அந்த பிட்டா எப்படி ரிமூவ் பண்ணிடுவோம். இருக்கிற ஒன்றரை பிட்டுல கால்சியம் ஆக்சலேட் கிறிஸ்டல் இருந்ததை நாம அப்புறம் இது எங்க இருந்தா இது எங்க இருக்கு தரவா ஸ்டடி பண்ணுவேன். எல்லா பார்ட்லயும் ஸ்டடி பண்ணுவோம். அதுல இந்த செப்பல் இந்த ஃப்ளவர் பார்ட் கிரீன் பார்ட் செப்பல் அதுல பெக்கூலியர் ஸ்ட்ரக்சரா இருக்கு. ஒரு லேயராவே கால்சியம் ஆக்சலேட் கிறிஸ்டல் ஒரு லேயராவே சிங்கிள் லேயரா மாதிரி இருக்கு. இது ஏன் எனக்கு இன்னும் மண்டே வரும். இன்னைக்கும் நேத்து கூட உங்களுக்கு அதுல ஒண்ணு என்ன நினைச்சு ஆஞ்ச அந்த செப்பல் ஆஞ்ச செப்பல்லையும் அடிக்கும் லேயர் அப்படி இருக்குதா வந்து போடுறாங்க. பாருங்க இதெல்லாம் என்ன புரியுதியா? ஸ்ட்ரக்சர் இது வெறும் லீஃப் வெஜிடேட்டிவ் லீஃப் கிரஷ் பண்றது இருக்கா ஸ்டெப் நோ இது இது ட்ரை மெட்டீரியல் நேச்சுரல். இது காலிக்ஸ்ல எதுக்காக ஏன் ஏற்படுத்தி அது டிஃபரன்ஸ் மெக்கானிசம் தான் நாம நல்லா தெரிஞ்சுக்கணும். ஆனா இத நான் ஃபர்ஸ்ட் 5 வருஷத்துக்கு முன்னாடி ஆராய்ச்சி பண்ணும்போது நான் இத பார்த்த உடனே லிட்டரேச்சர் தேடி அப்ப அதே வருஷத்துல ஒரு புதிய போட்டோசிந்தட்டிக் மெக்கானிசம் தட் இஸ் அலாம் போட்டோசிந்தசிஸ் அதாவது அவுட் கண்டிஷன்ல டொமேட்டோ ரோசா டிரான்ஸ்பிரேஷன் கண்ட்ரோல் பண்றதுக்காக அவுட் கண்டிஷன்ல டொமேட்டோ ரோசா வந்து கார்பன் டை ஆக்சைடு சப்ளை போட்டோசிந்தசிஸ் எங்க இருக்கு from calcium oxide crystal by decomposition they will supply carbon so it is called alarm photosynthesis but இங்க நான் கண்டுபிடிச்சிருக்கிறது alarm photosynthesis அதுல டொமேட்டோவும் இருக்கு. இது அலாம் போட்டோசிந்தசிஸ்க்காக இருக்கா இன்னும் எனக்கு கேள்விக்குறியாவே யாராவது இந்த மாதிரி என்ன செஞ்சாங்கன்னா அதுக்கு விட நமக்கு நிச்சயம் ஏதாவது ஒண்ணு அட்லீஸ்ட் ஒரு நல்ல இண்டெக்ஸ் ஜேர்னல் ஃபாரின் ஜேர்னல் போடுறாங்க. இது வரைக்கும் நான் ஒரு பேப்பர் கூட போடுறேன். தொட்டத்தை இடமெல்லாம் அந்த ஸ்டெம்ல ரூட்ல லீஃப்ல அதுல நேச்சரா இருக்கிறது சர்ப்பம் காலிக்ஸ் அந்த பாத்திரத்தை அதை பத்தி இதுவரைக்கும் இன்னும் நான் இந்த மாதிரி அனிமோம் லைஃப் ஸ்ட்ரக்சர் கால்சியம் ஆக்சலேட் கிறிஸ்டல் இருக்கிறது நான் கேட்பார்க்கிறேன். let me research next so these are some other crystal. There are also lot of research. Next so there are different kinds of crystals aanga as single of BSc பண்ணி கூட நடக்கும். ஆனா அது அந்த அளவுக்கு பரவலா போட்டு ஏமாத்தி வந்து நினைக்கிறோம். ஆனா புத்திசாலி சைனீஸ்காரங்க unusual forms of calcium oxalate graphite. இது இதே ஒரு என்னோட புத்தகம் சக்கரவர்த்தி மாதிரி அதுல கண்டுபிடிச்சு பான்கிண்டத்திலேயே 2 more types of graphite crystal டிஸ்கிரைப் பண்ணிருக்காங்க. பான்கிண்டத்திலே இதுவரைக்கும் 6 டைப், அவங்க புதுசா 2 டைப் டிஸ்கிரைப் பண்ணிருக்காங்க. இது என்னடா கிளாஸ்ன்றது இல்ல என்ன நமக்கு எங்க இதுதான். ஓகே, next this is another important biomaterial for physical science. Next, exploiting pollen and sporopollen for the sustainable production of microstructures. Next, so you can purify the pollen by removing the inner content and keeping the outer shell only, which can be used by any drug and it can be used for drug therapy. So this is a pollen differentiate pollen wall. Next, pollen wall structure. Next, so sporopollen composition, aliphatic polynucleotide derived polynucleotide. Next, synthetic biology. So far, scientists are trying to synthesize artificially such important structure biopolymers for pollen, but so far not successful. Synthetic biology that 1.47 million to billion. World's strongest biomaterial is sporopollen. Next, then epicuticular wax, that is also a lot of works. Next, epicuticular wax. Next, then farina on cells, photosynthetic structure. They are secreted by special glandular tricho. Next, so see the glandular tricho secreted the wax. Next, glandular tricho, pharyngia, farina, etc. So gums and resin, they are also lot of materials. Gums and resins, you may not be interested. Next, so muringai pistil, export muringai pistil. Why can't you take some result and improve the quality, product quality? Next, surveillance pistil, export. Tadalroot oil, I am used for Microsoft page on gymnosperm. Next, now as you are asked, so nanomaterial, biomolecules, nanomaterials, silver salt, and biomolecules, they will combine in the reaction take place for nanoparticles, new nanoparticles, artificial nanoparticles, it can be applied for anything. So reason, so there is a paper published by my colleague Johnson. There is a paper published. Next, these are edible glands filled with several organometallic compounds and also bioactive compounds. Organometallic compounds. Next, so these are the organometallic compounds found in such a glandular structure like silicon, tin, vanadium, palladium, copper, etc. Organometallic compounds. Next, so such organometallic compounds have high biological activity, antimicrobial and bacterial activity. Next, biologically inspired structures. Next, bioinspiration. Next, biologists and physicists can develop a new technology and other things. Study mechanism of fluid with germs. They have developed a bioinspiration material. These are some examples for bioinspired materials. Next, nastic movement, insectivorous plant. Scientists have bioinspired this mechanism to produce some other instrument. Next, so develop the bioinspired tactile, potassium mechanism. So multi structure of wheat stalks or grains, etc. Next, so conclusion, material should be studied and used properly, and compared to biological science, creative research is very important in physical research. First biology education, see what is how is that? இது இப்படி இருக்குன்னு மட்டும் but physical scientist, you have to explore other what are the functions. Next. So what is creativity? The ability to find out correct answer with the availability of 50% data of 50% are wrong. This is the definition given by very correct. Next. Creativity is seeing what others see and thinking what no one else ever thought. Many doctors have reported by Dr. Vijay. And many doctor candidates merely outline with clear way why they believe that to be working. The creativity crisis in the Indian education system. Next. So there is a need for creativity in India. Next. Need for more researchers in India to combat the current problems. Next. India's future is in innovation and creativity. Next. There is an urgent need, as explained by Vijay, and also there is an urgent need to shift the education system in India by focusing on conceptual clarity, critical thinking, problem solving, innovation, and creativity instead of examination-oriented road planning system. Next. So creative research can be done by cooperating, connecting, helping, etc. These are problems for creative research and integrated research. Next. Okay, thank you very much.
Hello. Thank you, Dr. V. Raj, for a wonderful and excellent presentation. You have given a number of innovative ideas, a lot of PowerPoint presentation, with a lot of clippings and videos. Thank you, Dr. V. Raj, sir. So may I have the honor and privilege to invite Dr. G. Ravi, Associate Professor, Head of the Department of Physics, to honor Dr. V. Raj with a short piece. May I now invite Dr. L. Arun Jose, Assistant Professor of Physics and Civics College, Palangote, to give away the memento and certificates to Dr. V. Raj. Sir, and it's time for lunch. I think you are feeling hungry. Is it clear? It is arranged at the physics department in the physics lab. Is it clear? So you can break for lunch there. And those who are selected for oral offline paper presentation are hereby requested to upload a presentation details in the system. And you can break for lunch. Is it clear? So the next session starts at 1:30. Be fast.
Recording stopped.
Excuse me, Dr. Ashika Shirley is here. Dr. Ashika Shirley. You don't clarification.
Thank you.